Today we're going to look at how to find the volume of cylinders. Volume is how much something can hold or how much space something occupies. So we might be talking about how much water can I fit inside of a container. That would be volume. How much cereal can I fit in this box would be volume. And when we take to find volume of cylinders, we're going to have a formula that'll be given to you on your reference sheets for ISTEP. So volume of a cylinder you can see right at the bottom here. Volume of a cylinder is pi r squared h. So when we look at the formula, make sure we know what the different pieces of this are. Pi, we've talked about, is about 3.14. R stands for radius, and H stands for height. Okay, if you look at our formula here, you don't have to necessarily know this, but just a little background information for you. You look at the formula, part of this should look familiar to you. Part of this formula looks like what?
Circumference.
Area of a circle, right. Area of a circle was pi r squared. All we got is an h on the end of it. Okay. Basically what we're doing is the circle, for our cylinder, our base is a circle. Okay. We go back, look at what we talked about with a rectangular prism. For a rectangular prism we talked about length times width times height, but we could have done area of the base times the height. Well, on a rectangular prism, our base is a rectangle. Area of a rectangle is length times width. So area of the base times the height, same thing on a cylinder. Area of the base is a circle, so we do pi r squared times the height. It's kind of like taking a circle, find the area of that, and then saying we're going to stack a bunch of circles on top of each other. The circles are this tall, then you multiply, and then that tells you what that volume is. Okay, again, basically if you can understand what the different parts of the formula are, then that's good enough for now, but just a little background on how we come up with that formula. So we look at example 1. Jenna and Ricardo need to buy a tank large enough for 25 zebrafish. The tank needs to have a volume of 2,310 cubic inches. How can Jenna and Ricardo determine whether the cylindrical tank can hold the zebrafish? So if we look at our tank here, we can see they've given us a couple of measurements here. We have 48, which would be the height, and we have 24, which would be the diameter. Okay, that's a big part we got to be careful about. All right, they show the picture of this again. If we come over here, right here would kind of be our starting point, if you will, underneath this line. That's our formula. And then we're just going to do some substituting. So we've got pi. They're telling us to use 3.14 for pi. And then they've got a 12 here. Now this was some kind of a magic trick because I didn't see a 12 in that other part. So we probably should show something happening. Where's the 12 coming from?
It's, they took the diameter, which is 24, and they cut it in half, which is 12.
Good. So 24 is a diameter, goes all the way across the circle. We need the radius, so we need half of that. So half of 24 is 12. Again, that should be shown on your paper somewhere. Okay? And so 3.14 times 12 squared times the height, which is 48. And then that gives us our volume. And if you just compare this, this is going to be large enough for our zebrafish. So this should work. Okay? Biggest thing when you guys use the formula, if you're finding the volume, Biggest things are basically, like we said, know what R and H stand for, which is radius and height, and then make sure you're using actually the radius, not the diameter, and then make sure you're squaring your radius. Those are kind of the top mistakes that people can make. Otherwise, it's pretty much, I mean, you get to this point, you can actually type all of that on your calculator at one time and it'll give you the answer. So example 2 is a little bit different. What's different about this than example 1?
It doesn't have the diameter or radius.
Okay, right. We don't know a diameter or radius. That's what we're trying to find, isn't it?
Mm-hmm.
Okay. What do they tell us instead on this problem? They told us the height on the last one. The volume, right. Okay, so they're telling me the volume. So this one, if we start here, I would have started with the formula right before that. I'm going to do some in-between stuff here that the book doesn't do. So that's our formula, and then we're just going to substitute for the formula. So the volume, they're telling me, is 300. The height, they're telling me, is 14. Radius, I don't know. One thing I probably would have done in that step, that same step that the book didn't do, is that we're going to use 3.14 for pi. I probably would have done that in the same step, but that's okay. Okay, so our ultimate goal here is to figure out what R is, figure out what that radius is. Well, we got a little bit of cleanup work to do first. What can we do first here?
Multiply the 14 and the 3.14.
Good. So on the right side here, this is all being multiplied. Commutative property says, well, go ahead and multiply it however you want to then. So 3.14 times 14, that's how they got the 43 and 96/100ths. And then what did they do? Divided, right. They're multiplying, so they divided by 43 and 96/100ths. Okay, so R squared is about 6 and 82/100ths. Well, I don't want R squared, I want R. So if they have R squared, how do we figure out what R is? Good. They're squaring it. We're going to take the square root, just like we did back on some of those area problems, area of circles. Okay, technically we add the square root. We should add a plus or minus in front of that. Radius is not going to be negative, but it's just for good habits that we know what we're doing when we're doing a problem that's not a radius or something. And then that comes out to about 2.6. Those little wavy lines, that wavy equal sign means about. And you might say, well, why do we have that? Well, it's basically it's because we use 3.14 for pi, which is technically an approximation. It's not exactly 3.14. Okay, but close enough. Our radius is about 2.6 centimeters. Example 3, we're talking about some safety barrels. If you ever wondered how they can just stay there, they fill them up with sand and things. So safety barrels are used to cushion cars on impact. If a city manager approves the purchase of 15 cubic meters of sand, how many barrels can be filled with sand? Use 3.14 for pi. Okay, so if we look at our safety barrels here, we can see we know the height and we know the diameter. So it means we can take our formula here. Now I see another magical number that wasn't there before. Okay, so how'd they get that? Good. We got 9/10. We got to take half of that. And you might say, well, 9/10. You know, now we got 45. 45 is bigger than 9. Well, remember it's a decimal. You can add a 0 behind that. That's 90 hundredths. Half of 90 hundredths is 45 hundredths. Okay, so that's our radius. And then they just did a 3.14 in place of pi if we want to modify that there. And then they multiplied. They got an approximate volume for one of these barrels. So if that's the volume of one of the barrels, cubic meters, we got 15 cubic meters of sand. What we're going to do, we're going to divide up our sand between these barrels, right? So take your total sand divided by how much would be in one barrel, and it comes out to be about 19.7. So 19.7, we can go two ways on this. They said we have enough, we're going to just get 19 barrels. Another option would be maybe we could get 20 barrels and just not quite fill them all the way. They'll probably still not blow away if we have them almost filled all the way. We look at the try it. Lynn is building a cylindrical planter with a base diameter of 15 inches. She has 5,000 cubic inches of soil to fill her planter. What is the height of the largest planter Lynn can build? Use 3.14 for pi and round to the nearest inch. We'll have to be careful to remember to do that. Okay, so when I see that word cylindrical, that means we're dealing with a cylinder. We see cubic inches of soil. That cubic units means we're dealing with volume. So I know we're doing a volume of a cylinder. So I'm going to start out with my formula. I'm going to substitute in some things they're telling us. So do we know what the volume is? Yes would be 5,000. Okay. So volume's 5,000. They said we're going to use 3.14 for pi. Do we know the radius?
No.
Can we find the radius?
Yes.
How do we find the radius?
Divide 15.
Okay, 15 divided by 2, 7.5 or 7.5 is our radius. And then the height, that's what we're trying to find. Okay, good. So this would be our setup to start out with. Once we got the setup, we're going to clean up a little bit here. So I'm going to go ahead on the right side. We can go ahead and multiply. We know 3.14 times 7.5 squared. And that should be 176 and 625 thousandths. Now this time it's just h. It's not like that r squared where we had to do the square root. This is h. So we got one more thing we got to do. Divide. Good. So we're going to divide. They're multiplying. We divide. Same on both sides. Keeps it balanced. And when you divide that out, you're going to get 28 3/10. Well, we got to remember now that they said round to the nearest inch, so that would be 28 inches would be to the nearest inch. So 28 inches would be about our height.